Okay, we're back, we're live, we're here. Guess what? It's 4 o'clock on Wednesday, and I'm here with Mike Hamnet, the co-chair of the Hawaii Energy Policy Forum, trying to wrangle these guys into a good discussion. Hi, Mike.
I'm going to work on it.
And one of them is Mitch Ewan, our hydrogen man. You know, little H.
That's right.
There.
Little H.
And our visiting fireman, can I say that?
Sure.
Is Pete Devlin from the Department of Energy in the United States of America, in Washington.
Yep.
D.C., who comes for many reasons, but among them the summit. There's a summit that's going on, and we'll talk about the summit and get kind of partial reports on the summit. That is the Clean Energy Summit going on right now. Today's the last day of the convention center. Okay, but before we get all serious, let's have a moment of joviality. We have Steve Chang from Hawaii Energy sitting together with Rob DeVeriturta from Hawaii Energy. He's waving. Let the record reflect he's waving. Okay, and we're going to hear about benchmarking because you got to know about that. You know, it's like navigation. How can you know where you're going if you don't know where you are? Right? Am I right?
Exactly.
All right. Tell us, Steve.
Thanks, Jay, for having us. First of all, Hawaii Energy is the electric ratepayer-funded energy conservation and efficiency program serving the islands of Hawaii, Lanai, Maui, and Molokai, and here on Oahu. Today's discussion is about Energy Star benchmarking. You hit it right on the head. How do you know where you want to go unless you know where you are? Energy Star benchmarking is a relatively simple, valuable tool to determine a building's energy performance. It's basically a report card. Benchmarks are commonly used in financial, for example, Dow Jones Industrial Average, S&P 500, so you can compare your stock portfolio to these indexes or benchmarks. Other types of analogies are automobiles, miles per gallon. So if you have a car that goes 50 miles per gallon, you can tell that that's relatively high compared to others. For healthcare, maybe you ought to check your blood pressure to see if you're normal or high or low. So this report card compares other buildings apples to apples in specific industries, like hotels compared to hotels, hospitals to hospitals, retail to retail. It's a usable way to determine a building's energy use in terms of energy use intensity. And we look at three criteria, mostly gas, electric, and water. And you put that into per square foot, and you can compare one to another, apples to apples. So what are the benefits of benchmarking a building? Well, is my building relatively efficient or inefficient compared to others? Or if I buy or lease a building, what can I expect my energy cost to be? And third, should I invest in energy management projects? So how does it work? Energy Star benchmark works in a 1 to 100 scale. 75 and above receives a label or a sticker. Why should you consider benchmarking? Building operators and property managers ought to do this to consider where they are so they know where they want to be.
How do you benchmark, Steve?
How do you benchmark?
I have a little pad of paper, and I write it down on a matrix on the pad of paper.
Yeah, it's pretty much information. You just need to know what your usage is and those energy criteria, gas, electric.
Is there a program I can use on the internet?
Absolutely.
I mean, like Excel or something. I fill in blanks, and it asks me questions or it sends me questions every day.
Yep, there is a website provided by the Department of Energy. It's the Energy Star Portfolio Manager. It's no charge. It's free. All it takes is your time and effort. Hawaii Energy will also be launching on our website a platform that will be more easier to use and download directly to the Energy Star Portfolio Manager.
Okay, now here's the big question.
Sure.
Why can't this be automated so I don't have to write anything down?
Perhaps that falls in the context of green button and something for the future.
Yeah.
And Jay, kind of the a takeaway here is when it comes to energy as well as in life, there's some things that we can control, some things we cannot. For example, things that we cannot control are natural disasters, hurricanes, tsunamis, and earthquakes, which causes and has caused power disruptions and outages in the past and will continue to do so. However, we do have we do have control on how we use energy, from the energy source we use, to the equipment we use, to the time of use, and the frequency of use. So I urge everyone to learn more about benchmarking by either calling me at 848-8583, and soon we'll be having some discussions on and websites assistance as well.
I love public officials who give their telephones on the air. 848-8583.
That's correct.
Wow. Okay, impressive. Okay, cross-examination, Mike?
How many people are involved in doing the benchmarking in terms with you guys? How many clients have you had?
For our program year, our goal is to have 500 businesses, including water, wastewater facilities, benchmarked for this program year, which our program year starts July 1 and ends June 30th.
In terms of benchmarking, how are you guys doing?
Currently, we just sent out a RFP and we've received proposals. We're currently evaluating on who the final recipient will be. That will contribute towards this 500 goals. The remaining, we're going to ask either people do it themselves, or we train them, or we help them do it as well.
A class.
Training class.
Yeah.
Absolutely.
Okay, Mitch, you have any rebuttal?
No, I think it sounds like an excellent program. I mean, we're looking at that at the university very carefully, particularly plug loads, which can account for up to 10.5% of your energy use. So you asked me about the Asia Pacific Conference. There's a good old friend of ours, Michael Pfeffer there, IBIS Networks, who made in Hawaii technology developed by Oceanit.
Exactly.
And you just plug these things in, and it's totally automated, and it downloads to your computer, and you can tell minute by minute, week by week, month by month, how much energy you're using at your plug. Did I leave that coffee maker in all week and look, or all weekend, or all my printers in, and look how much energy I wasted over the weekend? I wasn't printing this weekend. Why did I leave my printers plugged in? It's really good.
I was thinking of that when I asked you that question. Sorry.
Okay, yeah,
Yeah.
that's it. That's my comment.
Okay, Pete.
Yeah, sounds good. That's all I can say.
Okay, so you got support here in general. Let me add one thought, is that you take that Oceanit project, IBIS, IBIS, and Mike Pfeffer, and he's been here to discuss it. It only tells you, it only gives you your use numbers, right? Your benchmark, as it were.
Correct.
The next issue is to completely automate it. And what I really like about that possibility is there will be, it's not a prediction, it's a fact. There will be somebody who develops this kind of software that runs off the benchmark, as you say, where you can tune how your house is going to work. You can have it your way. It's coming. 2 years, maybe.
Right.
No disagreement.
No.
No.
You take it to the bank.
Thank you, Stephen. Thank you, Rob.
Thank you.
All right, can you guys go back to your office and start working on the next one? Okay.
Next week's topic.
Aloha nui loa.
Thanks, guys.
Thank
Thanks,
you.
guys. Finally, alone.
You got your echo back.
Okay, well let's get serious.
All right.
You're here about hydrogen.
Fuel cells, yeah. Hydrogen fuel cells,
What
right.
is it about hydrogen that's so interesting?
Well, I guess the most interesting thing about hydrogen is it can be made from so many different things. You can make it from fossil fuels, you can make it from renewables, you can make it from solar, thermal, geothermal, wind power. So that gives us a lot of diversity in terms of the sources, which gives us a lot of possibilities in terms of never being dependent on a single source. And that's kind of what we're about in terms of petroleum. Petroleum is 98% of the transportation sector right now. So the whole idea is to try to become diverse, develop domestic sources, and the other part is fuel cell vehicles themselves are more than twice as efficient as your typical combustion engine vehicle, and the only emission is a little bit of water vapor. There's no emissions.
So I have a dream.
Yeah.
My dream is that I can buy a hydrogen car,
Mm-hmm.
drive it around. I can top off the battery sometimes,
Mm-hmm.
or otherwise I can top off the hydrogen in there.
Yeah.
I can go from both ends and make this thing run a little further.
Yeah.
And this car is not going to be much more expensive than my existing gas car. And this car is going to be here, in 2 years.
Yeah. Well,
Is it a dream?
That's
or
not
is it
that
pie
far
in the
away.
sky?
We're working on to make that a reality. 2 years maybe a stretch, but close. They're already rolling them out in Southern California, and relative to this kind of technology, it is affordable. It's a lease program, $3,000 down and $499 a month, but that $499 a month gets you the car, the fuel,
That's great.
and the maintenance. And if the car ever needs to be serviced, somebody comes and gives you a loaner, and then they take it back and service it and bring it back to you. So it's kind of a pretty fancy service. The price is a little bit higher than typical, but that's happening today. So what we're trying to do is make that happen here in Hawaii, and the other targeted area is New England. And so a lot of what we do, Mitch, H&EI, and others, we talk about how to make that possible. How can we get hydrogen on the island and get people to start thinking about doing that?
What's going to be required to do that, Pete?
That being the infrastructure?
Yeah.
Well, that's what we've spent a lot of time planning since I was last on your show. And we're looking at things like federal properties that are not being used or underutilized could be made available. For example, we just finished the study. I think I told you about this last time a year ago, just about a year ago, that we were doing the study, and it was in a place called Fort Armstrong, which is right down in Ala Moana. Is that how I say it?
I remember it well.
Yeah, okay.
It's right here.
So we did that, and we released the study about 5 days ago. So that is a potential project that would use Government Service Administration land that's not being used. It's a flat top, nothing on it, and you would do an enhanced use lease with the federal government. So you got the land for free, and you put a station there, and have the private sector, have industry run the thing, even though the land's owned by the government.
So the government would buy or rent the land,
Essentially, yeah.
and then it would in turn rent that to an entrepreneur who's going to fund the station, get the capital for the station, build the station, and so forth.
So the government has title to the land. So they don't have to buy it. They would provide it. And enhanced use leases are usually close to free because you're doing something good for societal reasons.
Yeah.
So it's not like you're going to charge the average rate. So practically give them the land for free and help develop a way to make revenue from generating hydrogen.
So what did the study find out about that?
Well, we found out that you can make hydrogen right here in Oahu, and you can make a little bit of money doing it.
The entrepreneur or the person who develops the renewable.
The entrepreneur
but the guy who has the station is also doing the renewable.
Yes,
that's the message.
True. That's true. So there's a couple things here. We didn't think we'd be able to see a business case in Hawaii because everything's so expensive, land and everything else. But the idea here is to take that land and use it for solar PV arrays, and they would be roofs basically for roof-covered parking lot. Okay, so you get revenue from the solar array. You get revenue from the rented parking lots, and you make hydrogen and sell it to the public. And between all those three things, you get a modest return on investment and a payback of about 5.5 years. And that's the first time we've ever seen a net positive payback, in this kind of...
I love it.
Yeah.
I love that idea. When they first came out with PV, my original thought was that with net energy metering, which is going to go away, of course, but was that the old couple, the retired couple, would take their backyard and they would put PV cells all over their backyard, and they would sell, the energy back to the utility, and that would enhance their income. That and Social Security, and they were in great shape
for life.
For life, and doing good things. But you're going to make this possible in a much more creative way, I think.
Yeah.
and you're going to build a fleet of hydrogen cars in the process.
Well, we're working on that. This was just a feasibility study.
So
but
when is it going to happen?
We did a lot of
Have
modeling
any money
on it.
for it?
Very little. Might be able to help some. We paid for the feasibility study, so that's something anyway. Yeah, so the whole idea is to show where there is a business case and private sector can step up with a little bit of help from the federal government. And as far as the fleets go, since I was here last, we've launched a couple of fleet projects. Two of them are on the mainland with parcel delivery trucks, fuel cell powered parcel delivery trucks. And one of them is going to be deployed here, demoed and deployed here, and it's a refuse truck. So we're going to build a fuel cell refuse truck. And why would we do that? Well, last time I was here, I talked to you guys in Honolulu, the city of Honolulu, the state, and some others, and we thought, wouldn't it be great if you had like a not only zero emission refuse truck running around in Honolulu, but one that doesn't make very much noise.
Yeah.
Now this thing doesn't make any noise.
Why I have this fantastic image in my mind of this refuse truck, which, I mean, aside from the hydrogen aspect, it uses the refuse
To make the hydrogen.
to make the hydrogen to run the engine, okay?
Yeah.
And by the time the refuse truck gets to the dump, it's empty.
Yeah.
What do you think?
You're basically hauling your feedstock for your next refill. I love that idea too.
A trip to nowhere. Okay, well, on that note, we're going to take a break.
Yeah.
Okay. The far end is Mike Hamnet. Next to him, Mitch Ewan, then Pete Devlin from the Department of Energy. I'm Jay Fidell. We're here in Hawaii, the state of clean energy, and we are going to take a break, I promise you, right now.
Hello, I'm Martin Despang, and I'm the host together with the one and only Ali Yamashita, and our show is called Urban Transcendence. And Urban Transcendence is about identifying where we have a unique situation of a vibrant city in one of the most beautiful natural environments. So how these two can coincide, sometimes conflict, how they could find reciprocity in the 21st century is what we're excited about. And we're planning on bringing in a diverse body of guests, both from the arts and the science and the established and the wise and the emerging generation. So hope you will join us. We'll always be on Thursdays from 1 to 2 p.m. Thank you.
Okay, we're back. I told you we'd come back, and like MacArthur, we came back. He knew what he was talking about. Okay, and here we are. We're talking about Hawaii, the state of clean energy. We're talking about hydrogen in Hawaii from the federal point of view with Pete Devlin of the United States Department of Energy and local co-hosts and experts in the area. Mitch Ewan, who lives and breathes energy. How do you do that?
He lives and breathes hydrogen.
Hydrogen. Sorry. It was a great line, but you finessed it.
You made it better.
That's Mike Hamnet, co-chair of the Hawaii Energy Policy Forum. So, you were talking during the break about, new black boxes that can do chemical changes on, methane, making hydrogen, and all kinds of scrubbing this and fixing that and sort of bringing hydrogen into the mainstream. And it's almost like, why didn't we do this before? What's holding us up? Because if we work with hydrogen, yes, we will have a nationwide fleet of hydrogen cars. It will be in great shape. And I think everybody at this table, I'm not sure I have your agreement on this, but everybody at this table feels that the future is in hydrogen, right, Mike?
Eventually.
Good answer.
We take that as a yes.
Yeah.
So, what's holding us up?
Well, okay, so it is technically feasible to do this, take landfill gas and make it into fuel for your vehicle. And one of the biggest challenges is cost. We have a scale in gasoline and diesel that's beyond belief in terms of how much is actually made and consumed. And so as a result of that, the costs are much lower than hydrogen fuel, and for that matter, fuel cell vehicles. So we've got to figure out how to, come up with these value propositions that offset that extra cost in the case of fuel, get enough fuel cells out there in the hands of users for various applications to get the manufacturing cost of the fuel cell down. And then, we can start competing with, internal combustion engines running on gasoline and diesel.
A chicken egg thing, though, in many ways, because you have to convince the public that they really want this.
Yeah, it is.
You want to begin us, but, the public in general. And it's like I remember we had one of those energy policy forum programs, and one of the panels was about transportation. And one of the questions that came up,
what's it going to take to get me out of my car? You just find a way.
That was my question. And they had a lot of trouble answering that, actually.
Yeah, exactly.
So
how are we going to do that?
Well, since last time, we've done more research on getting the amount of precious metal out of the fuel cell.
Mm-hmm.
The precious metal is what makes it happen. It's the electrocatalyst that makes the power. And so, we need to get a certain number of vehicles or some other application of fuel cells in the hands of the public to get those costs down. In the case of hydrogen here in Hawaii, we need to be very creative, like with that feasibility study, on every possible station.
Great idea.
To come up with a way to make it happen. So we've got guys like Mitch running around trying to figure out, well, if there's excess power here, or if there's cheap propane there, what does that mean in terms of cost of hydrogen? So we're looking at all these different scenarios here in Oahu and on the Big Island for getting some, parity in terms of the cost to the consumer, as well as working on the cars. Now, the cars is kind of dictated by automotive makers, automakers.
The federal government. Why don't you just tell them?
Just tell them to do it?
Yeah, tell them to do it.
Okay.
When you get back, send an email.
Well, let me just jump in there. I mean, they're doing it. At the Asia Pacific Conference this week, Toyota shipped over a fuel cell electric hybrid vehicle. We didn't even know that was happening. They did that on their own nickel, on their own initiative. And they're leaving it here until at least the auto show in March.
You got the key?
I don't have the key, but I know where to get it. I know where they hide it.
Well, that's a good sign.
That's a great sign. I mean, here you go. And they took the initiative. They brought it over here. We'll be able to, demonstrate it. Maybe take you for a ride and drive like you did in the GM
Bring
vehicle.
my camera.
Yeah.
We could bring it in here and have it on the program.
Yeah, maybe we do that.
Can we get it in the studio?
But I think it just shows that, the automobile dealers or manufacturers are investing a lot of their own money into fuel cell vehicles. And here we have our local Servco bringing in a vehicle that they had on display, and they're going to be having it, operating here on Oahu to demonstrate it.
Doesn't that make you feel good? It's like, you've been touting this for how many years? All of a sudden, the big guys all of a sudden agree?
Yeah,
that's
a
nice.
long time.
Pete, in terms of the feasibility, what technology is going to be involved in making the hydrogen? Is that an on-site?
On-site water electrolysis. So you take water, split it, make hydrogen and oxygen, use the hydrogen for the fuel. And that's being done by the power supplied by the solar array. So solar array is given, first it makes a nice roof for renting,
for
parking. It's going to make power that can be used in buildings, and then it's making hydrogen. So between those three things, rental charges, power offsets, not really selling power, but there's a giant federal building across the street that could sure use some cheap power.
Sure.
And then, making the hydrogen. So all those things, create a situation that could be a net positive return.
And what kind of volume of hydrogen does it need to kind of make it pencil out financially?
Yeah, volume wasn't a big consideration because of those other two things. So we're seeing it being possible for just under 100 kilograms a day, which is 20 cars a day, or some fraction of buses, maybe 3 buses, something like that. So we're talking about a cost that is still, within striking distance of being competitive. It's not a direct parity with gasoline or diesel, but on a per mile basis, because you get that energy efficiency improvement, it gets pretty close.
And what is the efficiency, the comparison?
The efficiency for, this is a rule of thumb, so I can't really say this is what it is, because it always depends on the car, the vehicle, and all that stuff.
Right.
But it's about 55% or upper 50% for the fuel cell, and for your typical vehicle on the road with combustion engines, it's in the 20s, usually about 28%. So
So
Twice
something
as
twice
much.
as expensive.
yeah, it's twice as efficient,
Yeah.
with your typical vehicle. And there are limits to how how efficient can you make an internal combustion engine.
Right.
And we haven't reached that limit yet, which is great. I mean, we want combustion engines to be more efficient, but a fuel cell is inherently more efficient.
Mm-hmm. Well, Mitch, you're working with the science of this all the time. You guys are doing so many experiments at HNEI.
Yeah, sure.
And you must be looking at the literature. Some technologies are going to be flat for a while. Other technologies are going to have disruptive improvements. Where does hydrogen fit? Is somebody going to come up with another kind of hydrogen cell that's way better? What does it look like from your point of view?
I would have thought like a year or 2 years ago that electrolyzers were at their peak efficiency, and now there's new electrolyzers coming out that are 10 to 15% better, more efficient, and half the price. And so that's really encouraging. So yeah, I mean entrepreneurs go out there in their garage and they tinker away at this stuff, and all of a sudden they have a eureka moment, and they come out with something that's cheaper, better, faster, and continually surprise us. So there's no such thing as saying, oh, we've maxed out, we can't get any better. We can, and people are doing it right now today. I also want to talk about, how do we get the general public, involved in this? And I've been banging the drum of getting our public transportation system, our buses, the bus operating on hydrogen. That's the best thing we can do. And then every single taxpayer in the county can get the benefit of that. And we were talking to the city and county just the other day, and one of the big benefits is, look at Waikiki. You don't want to have these big old buses sitting there idling, spewing
air
out
conditioning,
spewing out diesel fumes and making all this noise. Where you can have kind of like a stealth bus, comes in there, doesn't have to run this big engine just to keep the air conditioning running. It's all electric drive.
Who's going to pay the spread, though? That bus is going to be more expensive than a conventional bus.
Actually, with a little bit of volume, they're going to be pretty competitive.
It's getting close.
The